One type of arithmetic example you might see will give you certain terms and ask you to find the pattern. So this one says the 4th and the 12th terms of an arithmetic sequence are 100 and 0 respectively. So they first want us to figure out what is the common difference. What were they adding or subtracting by? So the way that I do it is through setting up a system of equations and using substitution, personally. So for the 4th term, I'm going to say a sub 4 is 100. And then the 12th term, so a sub 12 is 0. So when I'm setting up my explicit rules for both of these, for the 4th term, I know that my actual term is 100. So the 4th term is 100. And then that equals, my explicit rule is a1, which we don't know, plus d, which we also don't know. N, however, is the 4th term, so it'd be 4 minus 1. So I could use this to get either a1 or d by itself, because those are my two unknowns. So I'm going to choose to get a1 by itself. So if I simplify this, we get 100 equals a1 plus 3d. So 100 minus 3d equals a1. Setting up my second equation for the system, I know the 12th term is 0. Still don't know a1 plus d. And this time n is 12 minus 1. What I can do now is I can plug in 100 minus 3d for a1 in the second equation. So I'm using substitution. So now it looks like 0 equals 100 minus 3d, so that replaced a1, plus 12 minus 1 is 11, so 11d. So if we simplify this, we can find the common difference. So we have 0 equals 100 plus 8d. So negative 100 equals 8d. So if you divide by h, you get d equals negative 12.5. So our common difference is negative 12.5. So that's what the first question was asking. The second question is asking what is the first term in the sequence. So I can find that by plugging in d into this equation, because we have the first term isolated. So we know a1 equals d, or equals 100 minus 3 times d, which is negative 12.5. So if you evaluate 100 minus 3 times negative 12.5, you get that a1 equals 137.5. So finally, to put it all together, to write our explicit rule, we needed d and a1. So our explicit rule for this arithmetic sequence would be an equals 137.5, which is our a1, minus 12.5, or you could have done plus negative 12.5 times n minus 1. So that is the explicit rule for this sequence. And you could use it to find the 1,000th term, the 1,000,000th term, and that's what this would give you.